All right, today we're going to be applying infinite limits, specifically in the concepts of finding asymptotes. Uh, we start first by looking at the horizontal asymptotes of the graph. And if you look through the notes in the very beginning of this, you see that we get a horizontal asymptote for every limit as x approaches infinity or limit as x approaches negative infinity for a function. You see in this first example, we took the function and I made two tables to find the limits as x approaches infinity and the limit as x approaches negative infinity. Figured out what both of those were. They were both the same, 1/4, and so we have y equals 1/4 as a horizontal asymptote. When it comes to horizontal asymptotes, we may have one of three situations really happening. We can have either no horizontal asymptotes, we can have one horizontal asymptote, or we can have two. And that's what we're going to see in all of these problems. So let's look at this now you try problem. We're finding the horizontal asymptotes of the graph y equals absolute value of 4x squared minus 5x plus 7 over 2x squared plus 3. So I'm going to just go ahead and type that function into my y equals screen. Absolute value is found in the math num menu. So I take the absolute value of 4x squared, come on, there we go, minus 5x plus 7 over quantity 2x squared plus 3. And I'm going to go ahead and find the limit of this as it approaches positive infinity and negative infinity. So I set up my table to ask, and then I go to my table. And I'll put gradually increasing values in for x, 10, 100, 1,000, 10,000, 100,000. You should see by now that it looks like that limit is going to be 2. So the limit as x goes to infinity of the function is positive 2. And I'll do the same thing going to negative infinity. Negative 10, negative 100, negative 1,000, negative 10,000, negative 100,000. Oops, I missed a 1 in there. And again, in this case, as x goes to negative infinity, the limit approaches 2. So what does that mean? Well, that means that we have one horizontal asymptote, and it's going to be the line y equals 2. And when we write asymptotes, we always want to write them as equations because they are equations representing lines that we're graphing. All right. Next, we talk about vertical asymptotes. In order for there to be a vertical asymptote, we need the limit as x approaches a, where the vertical asymptote occurs, to be approaching either positive or negative infinity from both the right and the left-hand side. You probably remember from pre-calc how you found vertical asymptotes. It's a little different from what we're going to do here. Usually they set up examples in pre-calc so that when you find a vertical asymptote this way, it actually is a vertical asymptote. But the first thing we want to do is we want to find our candidates to be vertical asymptotes. And those are all the places where the denominator is equal to 0 in the rational function. So I'm going to set this denominator equal to 0 and solve that for x, and you can do that however you decide to do that. You find that x equals plus or minus 2 are our candidates for where vertical asymptotes can occur. But now I want to find out, do vertical asymptotes actually occur there? And I'm going to handle them one by one. I'm going to find the limit as x approaches 2 to the left of the function. And I'm going to find the limit as x approaches 2 to the right of the function. And in order for this to actually be a vertical asymptote, those values both need to approach infinity or negative infinity. And one can be infinity and the other negative infinity as far as that goes. So again, I'm going to handle this numerically. I'm going to type my function in. And there we go. And now I'm going to set up my table to be automatic instead of an ask. And I'm finding the limit around 2, so I'm just going to have it start at 2, and I'll scroll the table around to get the values that I want to. And we see, as it's approaching from the left, the numbers get to be larger and larger positive values, so that limit is going to be positive infinity. And as we approach from the right, it's bigger and bigger negative values, so that approaches negative infinity. So indeed, that tells us we are going to have a vertical asymptote at x equals 2. I'm just going to write that over here on the side, and I know I have a vertical asymptote at x equals 2. Now I'm going to do the same thing to examine negative 2. I'm going to look at the limit of that function from the left and the limit of that function from the right. And so I already have my function typed in there. All I need to do is change where I set up my table. And you see that for both of those, the limit is approaching 1.5. So that means that there isn't a vertical asymptote at x equals negative 2. There's going to be what we call a removable discontinuity there, but we'll get to that later. Okay? So in this case, the only vertical asymptote is at x equals 2. Okay, let's go on. Let's do one more. We'll do the value try it for this. Go ahead and find the vertical asymptotes of this function, and pause the video, and when you're done, check out the solution on the video to see if you did things correctly. Okay, so the first thing I would do to find this is I would go ahead and type my function in there. X squared plus 5x plus 6 over x squared minus 9. Now my candidates here are where the denominator is equal to 0. So x equals plus or minus 3. So I'm going to find 4 limits here. The limit as x goes to 3 from the right. The limit as x goes to 3 from the left. The limit as x goes to negative 3 from the right. And the limit as x goes to negative 3 from the left. I'm going to go ahead and use my calculator to do all of those. So I first set up my table to find the limit around 3. And as it approaches 3 from the left, it's getting bigger and bigger negative numbers. So that's negative infinity for the limit. And as it approaches 3 from the right, it's getting to be bigger and bigger positive numbers. So that approaches infinity. Alright, that takes care of those two. I'll go back to my table setup and set up my table around negative 3. And those are both approaching 0.1666666666, which, if you may or may not recognize that that's 1/6. It doesn't really matter what it is, as long as it's not approaching infinity. That tells us that there's not a vertical asymptote there. And so in this problem, the only instance of a vertical asymptote that I have is at x equals 3. Okay, we'll end this video here and continue with the examples from this lesson in the next video.